Electronic ballasts differ significantly from magnetic ballasts when it comes to energy efficiency and the impact of switching them on and off frequently. With magnetic ballasts, there was a general guideline to avoid turning fluorescent lights off if you were only leaving the room for a short period, such as 2 hours or less. This was because the energy consumed by the ballast during startup, combined with the potential reduction in lamp life due to frequent switching, could outweigh the energy saved by turning the lights off for a brief period. Electronic ballasts, on the other hand, operate much more efficiently. They consume less power during operation and have a significantly reduced startup energy requirement compared to magnetic ballasts. This means that the energy penalty associated with turning them on and off is minimal. Furthermore, electronic ballasts typically extend the life of fluorescent lamps, including tape lamps, by providing a more controlled and consistent operating environment. Therefore, the guideline that applied to magnetic ballasts does not hold true for electronic ballasts and tape lamps. It is generally advantageous to turn off fluorescent lights with electronic ballasts whenever a room is unoccupied, even for short periods. Doing so will result in energy savings and can also prolong the lifespan of the lamps. Occupancy sensors are an excellent way to automate this process in office environments. These sensors detect the presence or absence of people in a room and automatically switch the lights on or off accordingly. This eliminates the need for individuals to manually control the lights, ensuring that they are only on when needed. The energy savings achieved through the use of occupancy sensors can be substantial. Studies have shown that in some cases, energy consumption for lighting can be reduced by up to 50% when occupancy sensors are implemented. The actual savings will depend on factors such as the occupancy patterns of the office, the type of lighting system installed, and the sensor settings. Occupancy sensors are relatively easy to install and configure. They typically consist of a sensor unit, which detects movement or infrared signatures, and a control unit, which switches the lights on or off. The sensors can be mounted on walls, ceilings, or even integrated into light fixtures. The control unit is usually wired into the existing lighting circuit. There are several types of occupancy sensors available, each with its own advantages and disadvantages. Passive infrared, or PIR, sensors detect changes in infrared radiation caused by the movement of people. These sensors are relatively inexpensive and reliable, but can be susceptible to false triggers from heat sources such as sunlight or heating vents. Ultrasonic sensors emit high-frequency sound waves and detect changes in the reflected waves caused by movement. These sensors are less susceptible to false triggers than PIR sensors, but can be more expensive and may not be suitable for all environments. Dual technology sensors combine PIR and ultrasonic technology to provide more reliable detection and reduce the risk of false triggers. These sensors are typically the most expensive option, but offer the best performance. In addition to choosing the right type of sensor, it is also important to configure the sensor settings properly. Most occupancy sensors have adjustable settings for sensitivity, time delay, and detection range. The sensitivity setting determines how much movement is required to trigger the sensor. The time delay setting determines how long the lights will remain on after the last detected movement. The detection range setting determines the area that the sensor will cover. It is important to adjust these settings to optimize the sensor's performance and minimize false triggers. When installing occupancy sensors, it is important to consider the layout of the office and the typical occupancy patterns. Sensors should be placed in locations where they will have a clear view of the areas to be monitored. Avoid placing sensors in areas where they may be blocked by furniture or other objects. It is also important to ensure that the sensors are not affected by drafts or other environmental factors that could cause false triggers. The installation of occupancy sensors can be a cost-effective way to save energy and reduce your carbon footprint. The initial investment in sensors can be quickly recouped through reduced energy bills. In addition to the direct cost savings, occupancy sensors can also improve the comfort and productivity of office workers. By ensuring that lights are only on when needed, occupancy sensors can reduce glare and eye strain, creating a more comfortable and productive work environment. To summarize, the efficiency of electronic ballasts, particularly when used with tape lamps, makes it economically and environmentally sound to switch off lights whenever a room is unoccupied, regardless of the duration. The use of occupancy sensors further enhances these savings by automating the switching process and ensuring that lights are only on when required. The factors to consider include selecting the appropriate sensor technology, configuring the sensor settings to match the specific environment, and strategically placing the sensors for optimal coverage. Firstly, understand the difference between magnetic and electronic ballasts. Magnetic ballasts found in older fluorescent lighting systems are less energy efficient and have a significant startup energy requirement. This means that turning them on and off frequently can actually consume more energy than leaving them on for short periods. Electronic ballasts, on the other hand, are much more efficient with lower startup energy requirements and reduced overall power consumption. Secondly, recognize the efficiency of Tate lamps. Tate lamps are a type of fluorescent lamp that is more energy efficient than older T12 lamps. When used with electronic ballasts, Tate lamps provide significant energy savings compared to older lighting systems. Thirdly, consider the benefits of occupancy sensors. Occupancy sensors are devices that detect the presence or absence of people in a room and automatically switch the lights on or off accordingly. These sensors can be a great way to save energy in offices and other commercial buildings, as they ensure that lights are only on when needed. Fourthly, evaluate the potential energy savings. Studies have shown that occupancy sensors can reduce lighting energy consumption by up to 50% in some cases. The actual savings will depend on factors such as the occupancy patterns of the building, the type of lighting system installed, and the sensor settings. Fifthly, consider the installation costs. The cost of installing occupancy sensors will vary depending on the type of sensor, the size of the area to be covered, and the complexity of the installation. However, the energy savings achieved through the use of occupancy sensors can often offset the installation costs within a relatively short period. Sixthly, choose the right type of occupancy sensor. There are several different types of occupancy sensors available, including passive infrared, ultrasonic, and dual technology sensors. Each type of sensor has its own advantages and disadvantages, so it is important to choose the right type of sensor for your specific application. Passive infrared or PIR sensors detect changes in infrared radiation caused by the movement of people. These sensors are relatively inexpensive and reliable, but can be susceptible to false triggers from heat sources such as sunlight or heating vents. Ultrasonic sensors emit high-frequency sound waves and detect changes in the reflected waves caused by movement. These sensors are less susceptible to false triggers than PIR sensors, but can be more expensive and may not be suitable for all environments. Dual technology sensors combine PIR and ultrasonic technology to provide more reliable detection and reduce the risk of false triggers. Seventhly, configure the sensor settings properly. Most occupancy sensors have adjustable settings for sensitivity, time delay, and detection range. It is important to adjust these settings to optimize the sensor's performance and minimize false triggers. The sensitivity setting determines how much movement is required to trigger the sensor. The time delay setting determines how long the lights will remain on after the last detected movement. The detection range setting determines the area that the sensor will cover. Eighthly, consider the placement of the sensors. The placement of occupancy sensors is important for ensuring that they can accurately detect the presence or absence of people in a room. Sensors should be placed in locations where they have a clear view of the areas to be monitored and are not obstructed by furniture or other objects. Ninthly, be aware of potential false triggers. Occupancy sensors can sometimes be triggered by things other than people, such as pets, moving objects, or changes in temperature. It is important to be aware of these potential false triggers and take steps to minimize them. Tenthly, maintain the sensors properly. Occupancy sensors should be inspected and cleaned regularly to ensure that they are functioning properly. The lenses of the sensors can become dirty over time, which can reduce their sensitivity. In conclusion, the use of electronic ballasts and Tate lamps combined with occupancy sensors can provide significant energy savings in office environments. By following these guidelines, you can maximize the energy savings and minimize the risk of false triggers. Consider energy audits to determine energy usage and potential savings, review lighting layouts for optimal sensor placement, and integrate lighting controls with building management systems for enhanced energy efficiency. Also, explore daylight harvesting strategies by dimming lights when natural light is available. For long-term energy efficiency, prioritize regular maintenance of lighting systems and occupancy sensors. When selecting occupancy sensors, consider factors like coverage area, mounting options, and adjustable settings. Implement a lighting control strategy that aligns with occupancy patterns and building usage. Evaluate the payback period for occupancy sensor installation, considering energy savings and installation costs. Properly programmed lighting control systems minimize energy waste and enhance occupant comfort. Investigate the compatibility of occupancy sensors with different types of lighting systems and ballasts. Building codes often mandate the use of occupancy sensors in certain areas to promote energy conservation. Educate building occupants about the benefits of occupancy sensors and proper usage to maximize energy savings. By turning off the lights with electronic ballasts and tape lamps when no one is in the room, you can reduce your energy consumption and save money on your electricity bill. Occupancy sensors are a convenient and effective way to automate this process and ensure that lights are only on when needed. There are also rebates and incentives available for installing energy-efficient lighting and occupancy sensors. Check with your local utility company or government agencies to see if you qualify for any of these programs. These incentives can help to offset the cost of installation and make energy-efficient lighting even more affordable. Remember to consider the overall lighting design when installing occupancy sensors. The goal is to provide adequate lighting for occupants while minimizing energy consumption. This may involve adjusting the placement of light fixtures or using different types of lamps to achieve the desired lighting levels. In addition to energy savings, occupancy sensors can also improve the comfort and productivity of office workers. By ensuring that lights are only on when needed, occupancy sensors can reduce glare and eye strain, creating a more comfortable and productive work environment. In conclusion, the use of electronic ballasts and tape lamps combined with occupancy sensors is a cost-effective and environmentally friendly way to reduce energy consumption in office environments. By following these guidelines, you can maximize the energy savings and improve the comfort and productivity of your employees. Furthermore, by integrating lighting control systems with building management systems, you can achieve even greater energy savings and optimize the overall performance of your building. Always consult with a qualified electrician or lighting professional to ensure that your lighting system is installed and configured properly. They can provide valuable advice and guidance on selecting the right type of lighting and occupancy sensors for your specific needs. By taking these steps, you can create a more energy efficient and comfortable office environment for your employees while reducing your carbon footprint.